Hi guys, once again welcome back to the brand new session of this operating system programming concepts. And today I'm just trying to show you the lab, okay, how to solve this programming problem that is related with the programming, like process synchronization, right, which is in lab 4. So the learning goals for today is like in this laboratory, okay, activity, you will be improving your understanding of for function, whereas also moreover, like you will also try to use the wait function, okay, and try to synchronize and execute the parent and all the kind of child processes. Okay, so let's begin the session, and I will just try to solve the exercise 1. I'll just go by which each requirement, okay, going through each requirement I'll try to solve each solutions. So this is the like a precedence graph. Okay, so what you have to do is in exercise number 1 is like you have to write a C program which uses this the function fork and wait to implement the following precedence graph. So here you have to be careful that process 1 is the original parent process. So this is the original parent process, and when it first calls for it creates a child. So it is going to create like call for system call, then it's going to create a child. You can like also it says that which is one of the P1L or P1 right also. Okay, so it's either this one or this one can be one of its child. Okay, and for example, if P1R, the parent will be P1L. So if you take this one as a parent, then this will be a child. So circles do not represent any processes, okay, but only the instruction flow is shown from here, the situation. Then P1L and P1R synchronize themselves in process 2, which is the original parent process. So it is going to synchronize itself to the process 2. That means it's again coming back to the same situation, that is a process 1. Okay, so this is just a diagram to represent, but actually these two childs are already synchronizing themselves back to its own parent process. Now what is going to happen is like says that okay, each of the instructions flow should only print a message. Okay, now let's go and check out the situation. Okay, let's try to work. So okay, let me solve this here. Okay, I have to include all the required libraries here, that is standard input output, the files, library headers. So we try to include the most important library header, that is the Unix standard data file. And lastly, we are going to use the system call wait. So system also wait. Also we have to include these header files. Now let's define the PID type. Okay, let's define the secondly we have to let's define the integer, because how I am trying to solve is I'm going to create a loop. I am trying to show you 2 times. Okay, so just 1 and 2 times. Okay, you guys can loop it how many times, okay, to just check it out the situation. So then 2, and the first thing you have to understand is like we just directly try to fork. We call the fork system call here, and we check it if it is a child or a parent. So this is a child, else it will be a parent, right? And there is a, like the situation. Okay, so it says that this is a parent root parent. Okay, and like either this one could be the child of this main parent. So printf stand up now. Okay, so the situation is like this, p1 will be a root, so you guys can print out like p parent. Okay, you guys can also index. Okay, so index will be I get PID, the process ID, and we'll just then create this one. PID is something like this one, right? So here it goes. And the next situation is like a child. Okay, also in the second situation we have to understand is this process is a parent. Okay, so of this process, so also be careful that we are going to use two fork. So there is another thing you have to understand. We have to create two PID, like PID, one for one child, one for one child one. So okay, again you for create you generate two children. So secondly you check that if this PID 2 is equals to 0, then obviously this will be a second child, else it will be a parent 2. I will write here child 2. Right, okay, now let's printf and check out the situation. Like, okay, for example, if it is a child something like this index of this child, and sorry for this one, okay, to include here child something this one, and PID, respective PID. So the index is something like the I itself, the PID is get PI, get PID. Okay, we can also get the parent ID. Okay, let's also print the PID. Right, so here it goes. Now lastly let's print out for parent. To say something like okay, you have to be careful. It is said that PL1 PLR, right? So let's not print something like child here. Let's write here P. This is R, because it will be it is the child of this one. This P L R. Okay, and PID of this one will be something like this. PPID will be also something like this one, and respectively it is going to okay. Now the most important thing you guys have to understand is like we have to do the synchronization. So how shall we do the synchronization? For that we need the status, that is status. We need the status for two, that is one for the first child and one for the second child. Okay, so what it is going to do, it's firstly it is going to exit like any numbers. Okay, and it is just going to So that's going to, it has to wait, prints out and it waits. Wait for that status, that is status 1, and similarly it also has to wait for that status. So wait the second status, and you have to grab the address. Okay, pass the address here, and what can be the, okay, let me check out the situation. So this will be something like, let's also print out here because this is P1, right? So let's do it P1 here. I think everything is okay, so let's try to compile and run it. Okay, sorry, here is PYD1, so let's try to compile and run it. Let's check out the situation. Yeah, the situation is here, that is it's starting from P0, P1. Okay, I will almost like this. Let's start from here 1, this equals to P1, just for the convenience to make it exactly right. So process 1, the main root process, that was P1, right? So if you can say it is P1, has a process ID 5960, and this will be the parent. Look, PPID, parent of this process, that is 5961 P1 area. This is 5961, the process ID is this one, and this, the parent of this one is 5960, that is this process 1. So and P1R, okay, if you go and check out here, P1R is the child of P1L. So if you go and check on here, the parent of this process is 5961, that is P1L. Okay, so similarly for also second, you print out similar like this, and lastly you also have to exit here, right? So let's close this status. Let's try to see the situation. Yeah, right now is the proper, because we just have P1M and P2. I just loop 2 times, that means I am just generating 2 processes, right? So process return 0, so everything is working fine here. Alright guys, so I'm done with this lab number, like exercise number 1 of lab 4, right? So okay, now yeah, now this is all done. Okay, you guys have to also, how do you synchronize? You just use the wait system call, right? And which flow of execution is first, PL1 or PL2? So the flow of execution first is PL1 is first, then PLR is coming, right? And then what is the purpose of the wait function is to synchronize. What happens if the process is killed